All right, let's jump right in. Welcome to this explainer. Today, we're diving into an invisible cosmic force that literally shapes our entire solar system. Yep, we are talking about the solar wind.
Okay, let's get right to the core of this mystery. I want you to imagine a relentless storm blowing right through the near vacuum of space. We're talking about a million-mile-per-hour wind that, well, you wouldn't even be able to feel it. So how could something like that dramatically alter the planets around us? Well, today, we're going to unpack exactly what the solar wind is, how it's born, and, crucially, why it matters so much to us here on Earth.
Part 1. The birth of the solar wind. To really understand this force, we first have to travel millions of miles to its incredibly violent birthplace, the Sun's corona. Now, the absolute key thing to grasp here is that the solar wind isn't made of air like the wind blowing through your backyard. It's actually a continuous supersonic stream of charged plasma expanding outward in literally every direction. And as it rushes out, it drags the Sun's own magnetic field along with it, right into the depths of space.
You can kind of think of this environment as a massive cosmic pressure cooker. The Sun's outer layer, that corona, is unimaginably hot. We're talking up to 1.5 to 2 million degrees. And this creates a truly extreme pressure difference between that superheated corona and the near vacuum of interstellar space. The gas expansion from all that intense heat simply overcomes the star's immense gravity, and it just shoots plasma outward to create the solar wind.
And if we break down the actual makeup of this fierce wind, it's overwhelmingly made of simple protons, like 95%. Then you've got about 4% alpha particles, which are essentially just helium nuclei, and a tiny 1% fraction of heavier elements, things like carbon, oxygen, and iron. So, for the most part, it's really just a barrage of protons and electrons flying through space.
Moving on to Section 2, fast, slow, and flares.
So let's look at how this plasma actually travels, because it definitely doesn't all blow at the same speed. First off, it's super important we don't confuse the continuous, everyday solar wind with sudden, violent eruptions. The solar wind, that's always blowing. But events like solar flares or coronal mass ejections, those are transient. They're sudden, isolated explosions that fling massive chunks of highly energetic plasma out into space. Basically, the wind is the steady stream, flares are the sudden, unpredictable bursts.
Now, looking at the continuous wind itself, there's a really clear bimodal split in its speed. We've got the quote-unquote slow wind, which meanders from the Sun's equatorial regions at around 300 to 500 kilometers per second, which, to be fair, is still ridiculously fast. But then we have the fast wind that rushes out of these dark, cooler regions near the poles, known as coronal holes, at a blistering 500 to 800 kilometers per second.
And here's where it gets really cool. Because the Sun rotates roughly every 27 days, it twists these fast and slow streams into this magnificent, spiraling 3D structure. The physicist Eugene Parker first theorizes way back in 1958, which is why we call it the Parker spiral. It creates this beautifully complex pattern of high and low speeds that literally looks like the rippling skirt of a twirling ballerina as it expands out through the solar system.
All right, Section 3, Earth's magnetic shield.
So what actually happens when this million-mile-per-hour plasma wave slams into our home planet? Well, very fortunately for us, Earth has a built-in defense mechanism. It's a massive magnetic bubble called the magnetosphere. When the solar wind hits us, it compresses this bubble on the day side, the side facing the Sun, and stretches it way out into a long tail on the night side. It acts exactly like a windsock blowing in a heavy gale.
Our absolute first line of defense here is known as the bow shock. See, because the solar wind is traveling faster than the speed of sound, when it hits our magnetic field, it forms a literal shock wave. Think of how water builds up and deflects around the bow of a fast-moving boat. It's exactly like that. This invisible shield physically deflects the worst of the incoming radiation and plasma. It's our ultimate planetary protector.
Which brings us to Section 4, auroras and tech damage.
The thing is, this shield isn't perfect. It's highly dynamic, and sometimes those charged particles manage to sneak right through the magnetosphere. When they do, they get funneled down along the magnetic field lines directly toward the north and south poles. And when they smash into the gases in our upper atmosphere, they transfer their kinetic energy, causing those gas molecules to emit light. And there you have it. That's how we get the absolutely stunning northern and southern lights.
But it's not all just pretty lights in the sky. As our society relies more and more on technology, these same magnetic fluctuations pose some pretty severe risks.
A really strong gust of solar wind can cause unexpected electrical surges. We're talking transformer burnouts and widespread power grid blackouts. It can scramble GPS signals, completely mess with high-frequency radio comms, damage the tiny microelectronics on our satellites, and even expose passengers on high-altitude flights to a spike in radiation.
Because that threat is so real, scientists are actually proposing some wild active defense shields. Take the storm wall concept, for example. The idea is that if we detect a massive, severe solar storm heading our way, we could deploy satellites to release a rapidly ionizing chemical cloud into space. This would temporarily thicken Earth's magnetosphere, creating a sort of artificial buffer to deflect that powerful energy away from our fragile infrastructure.
Crazy, right?
Let's look at Section 5, Mars, a warning.
To truly appreciate our magnetic field and to understand exactly what's at stake here, we just need to look next door. Earth has this robust global magnetosphere generated by our churning liquid metal core. But Mars? Mars is currently unmagnetized. It only has these weak, localized magnetic fields sort of trapped in its crust. Basically, it has no global shield to deflect the solar wind.
And what happens when you don't have a shield? Well, the relentless solar wind basically acts like a cosmic sandblaster. It ionizes the particles in the Martian atmosphere, turns them into what physicists call pickup ions, and then accelerates them right out into deep space. Over billions of years, the steady, unending bombardment has literally stripped Mars of its thick atmosphere and its water, completely transforming a once potentially habitable world into the barren, freezing desert we see today.
Finally, Section 6, monitoring the storm.
Because space weather is so consequential. We're talking about everything from beautiful auroras to literal planetary destruction. Humanity has actually established a really impressive early warning system. We have a whole fleet of robotic space sentinels. There's the Parker Solar Probe, which is literally flying into the sun's corona to measure the wind right at its birthplace. We have SOHO keeping a vigilant watch for incoming storms heading toward Earth. And we've got MAVEN out there orbiting Mars, actively measuring how the solar wind is still stripping away the tiny remnants of its atmosphere today.
And just to put things into perspective, consider this astonishing number: 427,000 miles per hour. That is the speed of NASA's Parker Solar Probe as it physically dives into the sun's blistering corona. It's officially the fastest human-made object ever created. And it's out there right now, braving that heat, gathering the absolutely crucial data we need to understand this cosmic gale.
So I'll leave you with this thought to ponder. As humanity ventures back to the moon, and as we set our sights onward to Mars, we are going to be leaving the safety of Earth's magnetic bubble. We'll literally be living in the crosshairs of an active star. Mastering our understanding of the solar wind won't just be some fun exercise in science anymore. It's going to be an absolute necessity for our survival. Thanks so much for joining me on this explainer, and keep exploring.